Okay, guys, we did our color coding yesterday, and we answered our questions in relation to that. In terms of, this is all looking at how our derivatives relate to our mins and maxes, and how we can use our derivatives to find those extrema. So, I believe we're ready for this, yes? Yeah, because we just barely finished the last part. So, a little bit of definitions. Increasing and decreasing functions. A function f is increasing on an interval if any two numbers, x1 and x2 in the interval, where x1 is less than x2 implies that f of x1 is less than f of x2. So that's the idea that what I would say is that basically as your x values are increasing, your y values are increasing. So your graph is moving up. So like as you move right on the graph, your graph is moving up. Okay. A function is decreasing on an interval if for any two numbers in the interval x1 is less than x2, but that implies that f of x1 is greater than f of x2. So this is still, as you move to the right, your x values are increasing. But as you move to the right, your y values are decreasing. Okay? It's a fancy way of what they're saying. Okay, example 2. The graph of y equals f of x shown at right is defined on the interval -3 to 7. List the open intervals over which the function is increasing, decreasing, or constant. So, increasing intervals.
-3 to -1. Good job.
Now, keep in mind, when we list these intervals, we are listing them in terms of x values. Okay, so the fact that this value is at a -3x value, and this value here is at a x value of -1. So it's increasing on the interval from -3 to -1. Those aren't the y values, those are the x values, because we always give our x values or intervals in x values. Okay, what about decreasing?
2 to 7.
Constant?
-1, 2.
And I'm assuming open intervals, they're specifically saying open intervals because at those points, you don't really say it's increasing or decreasing or constant when it's a point that's meeting. Okay, note, a function is said to be monotonic on an interval if its first derivative does not change sign. Okay, so if a first derivative does not change sign, the vocabulary word is monotonic. And I think I looked it up last year, and it is monotonic as opposed to, there's another pronunciation.
Monotonic?
Yeah, or monotonic. I don't know. I think I looked it up last year, so I don't know. Good knows, you just have to know how to write it, yes? Okay. Which is why I sometimes run into some of these words in calculus until I start to teach them. Like, I know the word, but I only just know how I pronounce it in my head. I don't know if that's right necessarily. So maybe that's just me. But, you read words in the book, you know what they mean, but sometimes you don't know how to pronounce them. I don't know. Not often, but. Okay. How can we find the values of x on the graph of a function where it is increasing or decreasing or constant? Okay. If f of x is continuous. So note, it does have to be continuous for this to work. Because if you have like a jump discontinuity or something, or asymptote, this isn't, the idea is not going to work there. But if f is continuous, then the derivative will only change signs at a critical value. Okay? If f of x is discontinuous, then the derivative could change signs at a critical value or a discontinuity. So when we're looking at a derivative, there's going to be a critical value if it changes sign. Unless it's not continuous, and then again, the jump discontinuities or an asymptote or something like that would also cause critical values. Okay, how to find intervals of increase or decrease. Let f be a continuous function on the interval. Find the intervals on which f is increasing or decreasing. First of all, we've talked about this, find the critical values. How are we going to find critical values? What did we do yesterday? That is setting the derivative equal to 0, right? Okay. Now, in order to figure out, because here's the deal, we want to know not just what the critical values are, but is it increasing, is it decreasing around them? So we're going to talk about doing a number line chart, so kind of like a sign chart that you've done in the past, using these critical numbers. We'll choose x values in the gaps in between the critical numbers to test the sign of f prime to know if the graph is increasing or decreasing, and thus, if it's increasing or decreasing, if it creates a min or a max. Okay, so we'll get some practice in here. Note, your sign chart is not a valid justification. You must write a clear and concise statement communicating your mathematical language related to sign changes of the derivative. Do not use pronouns. Now, for example, the function g is increasing on the interval from -2 to 5 since g prime of x is greater than 0. So basically, since the derivative is positive, that means it is increasing. That's what I'm trying to think. I guess, yeah, probably it is increasing on the interval. What is it? It would be the function. Okay, so that's, I think, I know, because in my mind when I first read that, I was like, don't use pronouns. I'm thinking like he and she and, no, but it is a pronoun, yes? So don't just be generic and say it is increasing. Name it. Give it a name. Okay. Everyone would rather have a name, yes?
Yes.
Yep.
Not hey you?
Yeah.
Okay.
The way you wiggled your finger.
Hey you! Hey you there! Okay. So, example 3. Find the open intervals on which f of x is increasing or decreasing and justify. So, in order to find increasing or decreasing, we need to start by finding the derivative. So I'm going to kind of call this step 1. Okay. F prime of x is what?
2x squared.
Oh,
All right.
Mario.
Not nice.
I wasn't there yet.
Mario, I agree.
Okay. I wrote my derivative down. You check. Because in all honesty, he said that so fast that... Okay. In order to try find critical values, what do I do with this derivative?
Set it equal to 0.
Set equal to 0. So 2x squared minus 2x minus 4 equals 0. What would you like to do?
Factor
The 2.
Let's get rid of the 2. So 2 times x squared.
minus 2x minus
No, there's no
1x.
Okay, I say someone correct it,
Dang
please.
it.
Someone correct hey you over there.
Alright.
Okay. Now, and I will say, Doug didn't ask it this time, could we just divide that 2 out?
Yeah.
You can in this situation. It's an equation. You can divide it out. That 2 is not going to mean anything because it has no variable. Okay, continue. Did you factor more?
X minus 2x plus 1.
I will agree. So I have 2 times x minus 2, x plus 1. Officially, critical values are going to be what?
2 and -1.
2 and -1.
2 and -1, because officially you're setting x minus 2 equal to 0, or yeah, x minus 2 equals 0 and x plus 1 equals 0. So x equals 2 and -1. And those are my critical values. Okay, we're good there, yes? Now, we were not just asked to find critical values, though. We want to know, where's my graph increasing and decreasing? So these critical values are most likely mins and maxes. Probably one of each, right? That would make sense here. Now, we're going to, I didn't use the word sign chart, but I'm going to call it a sign chart. You've done these before. Okay, we did these back in Algebra 2. But we're going to do a sign chart. On my sign chart, I'm putting -1 and 2. And then keep in mind, this sign chart, we are trying to test the derivative. I want to know if my derivative is positive or negative, because that will tell me if my function is increasing or decreasing. Okay, so with that in mind, pick a number left of -1.
-2.
-2. Now, notice we're testing the derivative. So you can, if you want, put it in here. You could put it in here. Personally, the factored form is easier. But if we put in -2, it's going to be a negative times a positive. No,
-2 plus 1.
negative times a negative
Is positive.
is a positive. Is that what I missed out on?
I don't know.
I don't know.
Positive.
Regardless. So
Something.
-2 minus 2 is a negative. -2 plus 1 is a negative. A negative times a negative is a positive. So can we agree that that interval is positive?
Yes.
Now, if that interval is positive for f prime, what does that say that f is going to be doing?
Increasing.
Okay, so the derivative is positive, the function is increasing. What about -1 to 2?
0.
Okay, put in 0. 0 minus 2 is a
Negative.
negative. 0 plus 1 is a
Positive.
positive. Positive times negative is a negative. A negative derivative says my function will be
Decreasing.
decreasing. Put in something bigger than 2.
3.
3 minus 2 is
1.
3 plus 1.
4.
Positive and positive, which is a positive.
Increasing again.
My graph is increasing. So the idea here, increasing, decreasing, increasing, because these are positive, negative, positive. Does that make sense? Okay. Now, the directions were, what do we need? Find the open intervals on which f of x is increasing or decreasing and justify. So we got to put this into words.
Would you say like negative infinity to -1? Or do you have to say like?
Okay, so first of all, what is increasing?
F function of x.
Okay, so I'm going to write it as f of x. You don't necessarily have to say the function f of x, okay? But you can. I'm just saying we can't say it, right? So f of x is increasing on
The interval -infinity to -1
So yes. you can.
and 2 to infinity.
why?
Because they-
Because that's what it says. That's like,
Because what's positive?
It's a derivative.
F prime of x is greater than 0. And what's that? That right there is fancy speak for that right there is fancy speak for saying the derivative is positive. Do they want you to just say the derivative is positive? No, you're going to be better off saying f prime of x is greater than 0. Okay? What else do we know?
f of x is decreasing on -1 to 2 because derivative was negative. Since f prime of x is greater than 0. Less than 0. Dang it.
You could say since, because, whatever. Okay. Not horrible. I like these problems. This is a huge application that I feel like we use a lot. And again, I mentioned it throws me off that we're just now getting to it. But okay. When presented with a continuous function, knowing that the sign of the derivative changes at a point, as well as knowing how the sign changes, will give us insight into the existence of extrema. Because I know right now whether -1 and 2 are mins or maxes. And I believe that's probably what we're getting ready to talk about on the next page, isn't it? What would you say is happening at -1?
Max. Relative max.
A max. Why?
Because
It's increasing to that point, and then it's decreasing at that point. So at -1 is a relative or local max. We can't say absolute because we don't know enough about the rest. Well, here's what I know. It's a cubic graph. Guess what? It's also going to look something like that. Can we use that in our toolbox? Okay, so that right there tells me it's a max. Also, 2. It's decreasing down, increasing away. So, for those reasons, I know it's a max and a min. And this is obviously a non-calculator problem because we need to be able to figure this out without the calculator. But this is your other thing. My original problem was a cubic. I know a lot of times cubics look like that, but if we have 2 critical points, it's going to look more like that. Okay? Moving on. Okay. Okay. So, first derivative test is one of our big topics here. Let C be a critical number of a function that is continuous on the open interval. If f is differentiable on the interval except possibly at C, then f of C can be classified as follows. This is exactly what we just talked about. F of x, though the derivative changes from negative to positive, then f of C is a minimum. Because negative means it's going to be decreasing, positive means it's going to be increasing, right? If f prime of x changes from positive to negative, increasing to decreasing, then that's going to make it a relative max. If f of x does not change signs, then f of C is neither a minimum nor a maximum. Probably a lot of times it falls into a category of inflection points. Just depends on the scenario. Okay? Okay, so we'll explore how to find points of inflections and intervals where a function is concave up or concave down in the next lesson. So right now we're just talking first derivative test. Next lesson is second derivative test. The following chart will be helpful in summarizing and using correct vocabulary when justifying conditions. So, you see me use these a lot. Positive or negative, increasing or decreasing. I've already done both of those today, haven't I? Mm-hmm. Concave up, concave down. That's more with the second derivative test, okay? So, right here, some function behavior, okay? This right here is what we've just talked about. If my derivative is positive, my original graph is increasing. If my derivative is negative, my original graph is decreasing. Okay? If the second derivative, and again, this is more for Monday, is positive, then ultimately that's going to mean my original graph is concave up. Okay? It means the first derivative is increasing, but that means the original graph is concave up. If my second derivative is negative, that means my original graph is concave down. Also means my first derivative is decreasing. Okay? So, all good symbols and vocabulary there to know. Okay, 4. Given f of x equals x to the fourth minus 8x squared plus 1. Find the open interval on which f of x is increasing or decreasing, justify. Determine the x values of any local extrema. So this is basically doing what we just did, and then also classifying them as mins and maxes, which we unofficially just did, right? So, okay.
4x cubed minus 16.
Really?
I didn't even read that.
He was waiting for that.
Mario, I agree with that.
What do we need to do to start this problem? Oh yeah, find the derivative. Okay. And here,
Oh, no, I don't think so.
here's the deal.
Skip this.
Why does he do that? Because
he
he
knows
knows
it
it frustrates
annoys
you
me.
girls so much. That's why. Okay. We're going to set this equal to 0. He was just determined to get the
Wait,
derivative.
factor out of 4x. 4x.
That's awesome. Yep, what they said.
X equals equals plus or minus
Okay. Now,
That was
okay. How did you get there? Because we have two different directions I could go at this point.
You said each part equals
Okay, so could we at this exact moment set each part equal to 0?
Yeah.
Yes. 4x equals 0, x squared minus 4 equals 0. What's the other option?
If you keep going, you can FOIL that out.
Can we factor this out? The other option is to say x squared minus 4 is x plus 2 and x minus 2. And here's the deal. I'm not saying one is more right than the other in this situation. Okay? We're fine either way. Now,
two squares.
with this in mind, what are my critical values?
0, 2, and negative.
Order doesn't matter. Okay, so we have values of 0, negative 2, and 2. Those are my critical values. The only thing I will say is if you set x squared minus 4 equals 0. When you took the square root of 4, did you remember plus or minus 2? That would be my only word of warning. But I don't care which way you go here. I'm not sure about always.
No, I rarely remember it.
I would say, I feel like you are one that are guilty there. Although there are often times where I say, you guys will say the answer, and I just sit there and hover, waiting to write the plus or minus. So.
Doug or swoop in.
And then someone will swoop in because they just see me standing there. And that happens in all my classes. So.
Usually I just keep going and I'm like, oh.
Oh, she's waiting? What? Okay, sign chart.
Blonde.
Doug, you're going to get yourself in trouble here. Let's not start on any fights. It's a Friday. Let's just get out here all in one piece. Okay. Now, when we set up this sign chart, we are thinking about the derivative. I'm going to put negative 2, 0, and 2 on my number line in numerical order. Dang it. What?
I missed it.
Mine's uneven.
Oh, my
Yep,
goodness.
too.
Okay. So, silly me thought it was something of importance there that we overlooked. Okay. So, plugging into the derivative, here's what I'm going to suggest. And this is why I personally chose to factor. I would plug in right there. Okay. Could you plug in up here if that's where you stopped?
Yeah.
Yes. Personal choice, okay? So that's where we're going to plug in. So, a number less than negative 2. What kind of signs do I get?
Negative.
So if we use negative 3, it's going to be negative, negative, negative. 3 negatives multiply to be a
Negative.
negative. So that tells me the derivative is negative. And so what do we know about the F graph itself? It's going to be decreasing, yes? Okay. A value between negative 2 and 0.
Negative 1.
Negative 1.
Negative, positive, negative.
Okay. Negative, positive, negative multiplies to be a
Positive.
positive. A positive section on derivative tells me the original graph is increasing. 0 to 2, 1.
Negative.
Positive, positive, negative is a negative, and so my graph is decreasing. A number bigger than 2, 3.
Positive, positive.
Positive, positive, positive. And so my graph is increasing. Are you with me?
Yeah.
Okay. So officially, part A said find the open intervals on which f of x is increasing or decreasing and justify. So there's my start. F of x is
Increasing.
increasing. On
Negative 2, 0, and 2 to infinity.
negative 2, 0, and 2 to infinity.
Can you put the U or do you have right?
I know U stands for union. Can you? Can you? Maybe? I'm trying to process to make sure I don't get it wrong. Maybe. I'm going to leave it at maybe for the moment. I totally see your question. Okay, 2 to infinity. Did you give me a reason?
Since f prime of x is greater than 0.
And realize that will always be your justification for increasing. So f of x is decreasing on
Negative infinity, negative 2, and 0, 2.
since
F prime of x is this here.
okay. Now officially we still have part B to do.
Oh, okay.
Part B, we have the information, we just have to state our answers basically. Okay, determine the x values of any local extrema of f of x. So what do we know about our various critical values? What kind of specific local extrema are they?
Mins and maxes.
What is negative 2?
A min. Absolute min. Well, min. It's
No,
min.
we don't know.
It's just a
Relative or local? What's 0?
Max.
What's 2?
Min.
Are you with us as to why?
Yep.
Because we have to justify. Okay?
I am not with you on why 2 is a min.
Because we decreased from the left, so we decreased down to it, and then we increased away
Oh,
from
and
it.
these are all x values, not y values.
Correct. Okay. So, let's see. Let's talk about, we only have one max. And I just have maximum. I don't even have any, I just have max occurs at, where's my max? X equals 0 for a max.
Oh, I'm looking at the wrong.
Okay. A max occurs at x equals 0 since I really actually could do this 2 ways, but what does the derivative do at that point? F prime of x changes from, no, positive to negative. Okay. Mins occur at
X equals negative 2, x equals 2.
since f prime of x changes from negative to positive. And notice I was very particular in that the words are positive and negative. Increasing and decreasing as if we were talking about the function itself, f. But we are specifically using f prime of x because f prime of x is our work. That's our justification. That's what tells us it's increasing, decreasing, and thus creates maxes and mins. Okay. For each statement,
There's so much.
exactly. Sketch a function that represents the result of the first derivative test for a continuous function y equals f of x with a critical number at x equals c. Okay, so let's read our clues. F of x has an absolute minimum at x equals c because f prime of x changes from negative to positive at x equals c.
Oh. So, are you just
I'm thinking parabola.
drawing a parabola?
Could we just draw a parabola?
Yeah.
A parabola where the min is over c. Okay? Mine's not a parabola.
We could draw.
What's yours?
Mine, and here's the deal, is a parabola perfectly fine?
Yes.
Yes, it is perfectly fine. Mine, and I don't know if I looked at hers too, mine does something more like that,
Oh, like a W.
Like an exit.
which, it would be a quartic. But here's the deal, do I have a min there?
Yeah.
I have a min there. And here's the deal, when it says my derivative changes from negative to positive, well, negative derivative over here says it's decreasing. Positive derivative over here says it's increasing. Parabola was
do whatever we want.
perfectly a-okay. You can do whatever you want to an
Not
extent
like whatever-
of
Yeah.
that is an absolute minimum. So absolute means it has to be not just any minimum, but the minimum.
If you do an absolute value, can you? Oh wait, no, that's not.
That's a piece. It's a cusp.
Yeah, we want to stay away from that. Okay, B. F of x has a local maximum, x equals c, because f of x changes from positive to negative at x equals c.
No.
Like you could do.
An
cubic?
upside?
Yeah.
Okay? If we do a cubic, whoops, we do a cubic, what am I positioning above c? A max? Okay? So an option, and this is kind of the option I have as a cubic, is something like that. Did it end up lined up? Yeah, I think it ended up lined up. Close enough. Is that a local max?
Yes.
Yeah, and since it specifically states local max, we should probably stay away from an upside down parabola, shouldn't we? Because that would have an absolute max. Okay? And the fact that the derivative changes signs from positive to negative, so positive slope, negative slope, right? Increasing to decreasing. Okay, ready for C? F of x has no local extrema at x equals c because f prime of x is greater than 0 for all x greater than 0 and is strictly monotonic.
Does not change
Does that mean
I say, now I can guess what Kylie's doing right now because I see her flipped back.
Would it be just one straight line then?
would that be an inflection point?
That could be all of the above.
I have it as kind of an inflection point. It has to be a strictly increasing function. And as Kylie was reading, monotonic, if its first derivative does not change sign.
So it could be
So-
like y equals mx plus
Just
c.
a line. Yeah, just a
Like just a straight line.
I would have no extrema. If it's an increasing line, the derivative would be positive. Monotonic says does not change sign. I guess a line would work.
Or we could do the one,
What
what's
do
the
you
one
have?
graph called where it goes like this?
I have a version of a cubic, but not this version of a cubic. I have more of your traditional cubic that's just kind of something like that, where what's happening right there is that's technically your concavity is changing. Okay? So that's what I have. Now, again, I don't think a straight line would be wrong. Okay? That's why it takes me a moment to process your questions on that one. On all of these, but My entire graph is increasing, yes? And that's what matters. And on both sides of the derivative there, or on both sides of the point C, is my derivative positive? It is, because I have increasing line there. Okay. Since f prime of x is negative immediately on either side of x equals c, the function f of x has neither a local max nor local minimum at x equals c.
That's what I was gonna say.
That's what I was gonna
A
say.
what?
Basically just.
The opposite. I mean, it could be just a negative line, but it could be a negative cubic.
And I guess what they're saying here is that c is some... Okay, so let me retract that statement about it could be a straight line. Because what did it say up top that c was? C is a critical number. And on a straight line, you're not going to just have a random critical number in the middle. Something needs to be happening. So if there's not a min or a max, it's probably some type of inflection point. Okay, so, there's my reasoning. I'm going to retract the statement because C is defined to be a critical value. Okay, so yeah, I have mine kind of doing that thing where it's a decreasing curve, right? The derivative is negative, and it's negative immediately on either side, so negative and negative, right? Neither a local max nor a min. Same thing as last one, they just worded it way differently, didn't they? Okay, good.
Is that a tangent too? Or is that the cotangent? Because one of them was.
That's tangent, that's cotangent.
Tangent, cotangent.
I was trying to remember because I know we would know.
I don't know.
I was like, what are you talking? I'm thinking, is that a tangent line is what where the direction you were going before that's what I was like. Moving on. 6. Find the exact values of any relative extrema of the function g of x on the interval 0 to 2 pi. Justify.
Alright. 1/2.
1/2 minus cosine.
Oh! I was literally like getting there. I was getting there. I had like 2 more.
It was that one breath you did. Literally.
You can't breathe, Sophie.
1/2 minus cosine x. Oh,
I say we just tune it out and just say it anyways, like he did.
that's what I just did.
You're saying the derivative equal to 0, right?
Cosine equals 1/2.
When does cosine x equal?
Cosine x equals 1/2. I added my cosine x to the other side, and I just flipped them. And now I need any values on the interval 0 to 2 pi where cosine equals 1/2. So if we are in our chart or our quadrant 1 angle,
Pi over 3.
Pi over 6.
Oh, pi over 6.
pi over 3.
It's pi over 3. We did this yesterday.
I thought so too.
We did
And here's what I go with, guys. 30, 45, 60, right?
Yeah.
My 1/2 is there, and then my 1/2 is there. This is sine, cosine. I need 60, which is pi over 3.
That's
So
okay.
don't.
So, okay. We need pi over 3,
I was right.
and
5 pi.
we need the angle from all students quadrant 4. So what is the pi over 3 angle in quadrant 4 without turning and looking at the unit circle?
5 pi.
5 pi over 3.
I just love looking
Maya already told us. So.
You just have to remember that.
And the only reason I say that is because on a calc test, is the unit circle going to be in the room?
No.
What? If you were allowed to take the calc test in here, I would have to cover that up. That cannot be viewed.
That's dumb.
So,
I always get a picture.
Well, I'm gonna get a picture of it in my
Why don't you
calculator.
just point it and stuff? 'Cause we're
That'll be your
always-
background.
and the thing is, on a calculator one, you could just plug it in. It would be all the problems you don't get the calculator on.
No, I'm gonna put a picture of the
I'm gonna get a
The-
tattoo of
that-
it.
Oh my
I'm gonna get a
god.
tattoo.
But I'm saying,
right
but
here.
only half the test you get to use your calculator.
A
Okay.
tattoo of the
units are on
chart.
your
I think I'm
hand?
gonna get a tattoo of the chart.
Okay, guys. So I need a sign chart.
This is my favorite part of calculus, drawing these little.
On my sign chart,
I think this side in.
Yeah, S-I-N-E, not S-I-G.
Every time, yeah.
I'm doing a SIGN chart. Didn't realize I needed to specify here.
We do a sine and cosine.
Fair enough. Fair enough. In my brain, it's all crystal clear, but okay. So we're doing this sign chart.
Pi over
Huh.
There.
2?
No.
No, that'd be on the inside. No, that'd be
It's
pi over
1
2.
half minus 1 half. Oh yeah.
Help me out. How do we figure this out?
Pi over 2, right?
We could do,
Pi
why
over-
don't we do 0? 0's to the left of pi over 3.
It ended my interval just barely, but
And then 2.
Then 2 pi.
And 0. No. Pi. Sorry, guys. Pi would be the middle.
Yeah.
okay. Now, so sorry, I'm processing. My brain's struggling here. I feel like we need to plug it in.
Yeah.
Right there.
Yeah.
Okay. Sorry,
Pi
my
over 2 also works in there. So you
Okay,
can just
so-
do pi over 2.
if we use 0, the cosine at 0 is
1.
1. 1 half minus 1 is
Negative.
negative. Are you with me?
Yes.
I think so.
And my answer key agrees. Whew. Okay, so
Thank the Lord.
between pi over 3 and 5 pi over 3. I personally like pi. However, pi over 2 works. Okay? Technically 3 pi over 2 works also. But whatever floats your boat.
Positive.
I know the cosine of pi is negative 1 because I'm drawing the cosine curve in my brain. So 1 half minus negative 1 is going to be a positive. And then bigger than 5 pi over 3? Well, the cosine of anything bigger than 5 pi over 3. Well, cosine of, what do we say, 2 pi is what we're doing? Only because it's just barely there. Cosine of 2 pi is the same over here, so that's going to be 1. 1 half minus 1 is negative. So what's this graph doing? That was G prime up there. So G is decreasing, increasing, decreasing. Now, here's the catch. Well, okay. What's mins and maxes?
Pi over 3 is a relative, and 5 pi over 3 is a relative.
Are we okay with that? It's a min and a max? Okay. Now, here's the deal before we write it out. Find the
Exact values.
exact values. Exact means do we get to plug it in the calculator?
No.
Okay, so we need to know, we need to take pi over, and when it says find the exact values of any relative extrema, we're looking for the y values. It's not just asking me where are the mins and
We
maxes.
plug it into the original.
Last problem said determine the x values of the local extrema. Here it's we're plugging them in because we want to know the exact values. Plugging them in where?
The original.
The original. So g of pi over 3. 1 half times pi over 3 minus sine of pi over 3. Yes?
5 or 6 minus square root of
1 half times pi over 3 is pi over 6 minus, okay, sine of pi over 3. I didn't fill these in earlier, but it is the square root of 3 over 2. That's your exact value, folks. I'm not going to do it. I mean, the only other thing you do is maybe a common denominator. Okay, let's get our other one, and then we'll write out our justification. We need g of 5 pi over 3. So 1/2 times 5 pi over 3 minus sine of 5 pi over 3. So g of 5 pi over 3 is,
Plus.
so it's minus, okay, so sine of 5 pi over 3. Sine of pi over 3 is still this. But what do we know about sine in quadrant 4? It's negative. So minus negative, so plus square root of 3 over 2. Yes? Okay. So I have written out G has a relative min of blank at blank, since G prime of X changes from blank to blank. That's the format I'm going for. Okay, because we need to justify. So G of X has a relative minimum of, no, I'm not doing, I'm talking minimums here. Where's my minimum? At pi over 3, which, what was that value? So my relative minimum value is pi over 6 minus square root of 3 over 2 at, when does that occur? X equals pi over 3. Since, what did G prime of X do in this situation?
Is,
Negative, positive.
yeah.
Yeah, right.
It changed from negative to positive.
It's hard to keep straight. It's negative, positive, decrease, and increase.
Don't worry, I feel you there. Okay. The more you practice writing that out, the better off you'll get with it. G of X has a relative max of, what is our relative max?
5 pi over 6 plus square root of 3 over 2.
At X equals 5 pi over 3. Since G prime of X changes from
Positive to negative.
positive to negative. Now, I will tell you, the reason I draw my arrows under the sign chart is because I feel like I can see, oh, it's going down and up. Oh, I see a minimum. It's going up, it's going down. I see a maximum. Because I always do, I have to stop and think, am I going positive to negative, negative to positive? So, okay. Side note, answer the question being asked. Are you looking for extrema, which is the y value, or the location where the extrema occurs, which is the x value? Okay. Well, let's at least try and get the next 3 problems are all going to be variations of what we've been doing. Okay, you've got the basics under your belt. These are all variations, okay? Because it's find the relative extrema, so that's going to be the y values. It's find the x coordinates of the relative extrema, and it's find the intervals of increasing, decreasing, and x coordinates of relative extrema. Okay, so you'll have the notes answer key available to look at if you want to check out how any of those work.
I have the derivative.
Me too.
What is it?
2/3 times x squared minus 4 to the negative 1/3 times 2x.
4x over the cube root of x squared minus 1.
If you go one more step, which is what we're going to have to do here in a moment. Okay, so,
That's all.
okay, so, oh wait, time out. Are we okay with the derivative that Sophie and Mario did?
Yep.
The one that part that Sophie did. Are we good with that one? Yeah. It's a power rule times the chain rule. Okay, now, the part that Mario did. You do want to think about this before you set it equal to 0. So x squared minus 4 is going to go in the denominator. And I did go ahead and put it as a cube root down there. Or leave it with the 1/3.
And then
Okay.
3 goes in the denominator.
3 goes in the denominator out front. 2 and 2x is 4x in the numerator. Are we good with Mario's part now?
Yes.
Yes.
So I didn't feel like I could just write that one up there as easily.
Yeah.
Okay.
Jeez.
Oh, sorry.
Set your derivative. Now, okay, we are, general rule of thumb with a critical value is when does the derivative equal 0? When does a fraction equal 0?
On the top and the bottom.
No.
Well, when does a fraction equal 0 is when the numerator equals 0. So there's going to be a critical value at
0.
x equals 0. That's because that's when the derivative equals 0. Now, where else can critical values occur? When the derivative is undefined. When is my derivative undefined here? When your denominator equals 0. When is my denominator going to equal 0?
Plus minus 2.
When x squared minus 4 equals 0. Are you catching on to why I'm
doing the whole denominator?
Why aren't, because, okay, so I can do the whole denominator, but the 3 is going to divide away. So, okay, if I start solving this, I'm going to divide away the 3, and I'm going to have the cube root of x squared minus 4.
Okay, makes sense now.
And then how do you get rid of a cube root?
QB.
Are you with me? Sorry, I figured if you're asking the question, you're probably not the only one saying, well, why? Have I proved myself?
Yes.
Okay. X squared equals 4. X is plus or minus 2. Good? Okay. So right now, we have critical values at x equals 0 and x equals plus or minus 2. And I kind of already wrote up above, it's because when the derivative equals 0 and when the derivative is undefined or does not exist. Okay? Now, with that in mind, sign chart?
Yep.
I'm going to run out of time, aren't I?
Yeah.
What are we putting on here?
-2, 0, positive 2.
Okay. Excuse me. When you put in a number less than 2, and here's the deal, we don't really have factors to work with so much. I don't have any work showing, so if we put in, like, say, -3, well, on top, 4 times a negative is going to be a negative. On bottom, -3 squared is going to be 9 minus 4, that's going to be positive. A negative divided by a positive is going to be a negative. Are you with that?
Yep.
Okay, between -2 and 0, I'm going to use -1. I'm going to have negative on top. 1 squared minus 4 is going to be a negative. Negative divided by negative is a positive. Catching on? 1. What's 1 going to do?
Positive over negative.
Positive over negative, which is a negative. A number bigger than 2.
Positive, positive.
Okay. And you see where we're going with that, right?
Yeah.
Okay. The notes answer key may or may not already be available. I'll get that available. Okay. Do the homework for Monday. Okay. So you'll have 5.2 and 5.3 homework to check. And then we've got Monday, Tuesday, 5.4, Wednesday, Thursday, 5.5, Friday, Monday, 5.6, and then we've got to squeeze in a test and final exam review. So we're going to move quickly. We've got to keep moving.
Right.
Okay.